All right, my friends, let's see how it went for you. So I'm going to copy the fraction for the numerator as is, and then I'm just going to factor the denominator. So the denominator, if you factor x out first, you'd be left with x squared minus 4, and x squared minus 4 would factor neatly into x plus 2 times x minus 2. So I'm just going to write that. There we go. And again, we have a distinct linear factors case. And so the form would just be a constant over your first factor, a constant over your second factor, and a constant over your third factor. And a comment for when we get to part 2, where we talk about special forms. When we get to special forms, the procedure is the same, but the forms just look a little different. So anyway, the procedure is the hard part. So hopefully that part's coming along fine. All right, and then from there we switch modes from breaking apart to putting it back together again. And so we'd have a over x would need to be multiplied by x plus 2 and x minus 2, also known as x squared minus 4. And then the b over x plus 2, it would need to get multiplied by x and x minus 2, also known as x squared minus 2x. And then the c over x minus 2, it would need to get multiplied by x and x plus 2, also known as x squared plus 2x, in order to get the denominators to match the original one. Okay, let's see, multiplying stuff in, we'd have ax squared minus 4a plus bx squared minus 2bx plus cx squared plus 2cx. And that would all be over x times x squared minus 4, or whatever version you want to put, as long as you can see that you did get the denominator to match the original denominator there. I'm going to bring the original fraction down. There we go. So denominator battle is won. Now let's focus on making the numerators equal each other. So 5x squared minus 12x minus 12 would have to equal. Now let's group things in a way that makes sense. So I'm going to group the x squared terms together, and I'm going to factor x squared out on the right. So I'd have a plus b plus c x squareds. And then I'm going to factor the x terms together. So I'll just write plus, I guess. I'll have negative 2b plus 2c x. All right, and then lastly, we'd have the constant term, which it looks like negative 4a is the only non-x term. So I'll write it like that. Okay, now from here, we get our system of equations. So a plus b plus c must equal 5. And negative 2b plus 2c must equal negative 12, which I hope it makes sense. You could divide everything here by a 2 or negative 2, up to you, and make it simpler. And then last, negative 4a would have to equal negative 12. There we go. And so I have a system of equations. For me, it looks easiest to solve for a here in the last row, so I'm just going to do that. So a would have to be 3. And then you could back substitute, maybe, totally up to you. I'm going to back substitute into row 1 since I know a is 3. And then I'm going to subtract 3 over. So I know b plus c has to equal 2. And then row 2, I'm going to copy that, just dividing everything by 2. So I'd have negative b plus c would have to be negative 6. Then I'm going to add these 2 rows together. So I'd end up with 2c would have to equal negative 4. And c would have to equal negative 2. Now that I know c would have to be negative 2, I could back substitute right there. And so I'd have b minus 2 would have to equal 2, which means b would have to be 4. Now that I know C and B, I could back substitute those into row 1 here, and it would say A plus 4 for B plus -2 for C equals 5, and so A would equal 3. There we go. All right, my friends, what were the directions? Okay, write the partial fraction decomposition. So my conclusion would then be, therefore, 5x squared minus 12x minus 12 over x cubed minus 4x is equivalent to, so I'm just taking my a, b, and c values and back substituting them into my form. So it equal 3 over x plus 4 over x plus 2 minus 2 over x minus 2, or anything equivalent to that. There we go. All right, my friends, I hope you're off to a great start. We'll talk about special cases in the next lesson.